looked at acidic compounds or acids. And we started to look at those acids, and we learned that if you have hydrogen in the first spot, hydrogen ion, you have an acid. And there's actually two different types of acids. And I broke this up into two different videos because I thought that the other one was going to get pretty long. So that's the only reason why this is broken up into two parts. The last one we looked at your ions that ended, for your anions, that ended in IDE. So those were all your elements on the periodic table, hydroxide, cyanide, and those get hydro. The hydrogen hydro does not mean hydrogen. It just means that water has to be present in order for it to break down. Now with these next type of acids, these are going to have polyatomic ions, but your polyatomic ions are going to end ATE or ITE. So you have ate or ite. And with these, they do not get hydro in the name at all whatsoever. Hydro are only for your ide acids. Again, hydro does not mean hydrogen. It means water, hydro. So with these naming rules, if your polyatomic ion ends in ATE, all that you do is you take away the ATE and you put in IC instead. I ate something icky. So just take away ATE, put in IC. For these, you have ITE. If you have a polyatomic ion that ends in ITE, you just take away that ITE and you put in OUS. So Sprite is delicious is the way to remember that one. So I ate something icky, ate goes to ick. Sprite is delicious, ite goes to OUS. So down here, this CO3, when you find it on your polyatomic ion chart, CO3 is called carbonate. And with that carbonate, you just take away the ATE and it becomes IC, so carbonic acid. ClO2, when you find it on your polyatomic ion chart, that is called chlorite. So with ClO2 being chlorite, you take away the ITE and you put in OUS. So this is called Chlorus acid. So there are two of the elements that, again, they, as long as you follow the rules, I'm okay with that, but I'll always write them correctly. In order to make them flow a little bit easier, they left in the R's. So again, with that phosphorus and sulfur, the other one had carbon too, but carbon doesn't fall into this anymore. With your phosphate, it would become phosphoric. So if you just take away the ATE, it would be phosphic. But again, I will always give it correctly with phosphoric, or phosphite would be phosphorus. Sulfate is sulfuric, and then sulfite is sulfurous. So H2SO4 is actually called sulfuric acid. H3PO3 is phosphorus. Again, as long as you follow the rules, I'm not going to penalize you for that when we're writing them out. So if you gave me an answer here of sulfic acid, I'm going to correct it, but I'm going to move on with my day. I'm more concerned with you guys just learning and using the rules in this unit than getting nitpicky with all the exceptions, because chemistry is a ton of exceptions. So with these examples, again, I've got my document camera here that we're going to swap over to, and I've got 5 of them here. The first one says HClO4. H, that just means acid. So ClO4, I'm going to find it on my polyatomic ion chart. I was trying to look for one, and apparently I didn't grab it when I was sitting here. It must have, oh wait, there it is. Sorry. I was going to say, I usually keep one right next to me. So ClO4, when you find it on your chart, again, they're in alphabetical order. Cl is chlorine, but it's not over here. So you're going to kind of have to dig. And when you dig for this, right here, ooh, sorry, I'm off the chart. ClO4 is called perchlorate. So with our naming rules, I ate something icky. Ate becomes ick. So this is actually called perchloric. And then that H means acid. So we write the word acid at the end. ClO2, when we find it on our polyatomic ion chart, ClO2 is called chlorite. So chlorite when I swap it out and turn it into my acid, ite is us. So this one is called Chlorus acid. Bromic acid. Now there's no hydro at the beginning of this one. So because there's no hydro at the beginning, I don't have bromine. I'm going to have to find it on my polyatomic ions. So I'm looking for bromate because this was ick. This was called bromate. Ate and ick get swapped out. So bromate, when you find it on your chart, is up here. Let me see if I can get rid of that glare. Bromate is BrO3 -1. Acid means that hydrogen ions are present. So I'm going to start with hydrogen with +1. Bromate, when we found it, is BrO3 -1. So when I swap and drop, you end up with HBrO3. So it wasn't bromine because there was no hydro at the beginning. Ick becomes 8, or it goes back to 8. Cyanic acid. Again, there's no hydro at the beginning, so I don't have cyanide here. Ick is 8, so I need to find something that's called cyanate on my chart. So cyanate on my chart right here is OCN -1. Acid means that hydrogen ions are present. Cyanate is OCN -1. So +1 -1, again, when we swap and drop, it just becomes HOCN. Sulfurous. OUS means that this used to be ITE. Again, acid means that hydrogen ions are present. So sulfite is what I need to find on my polyatomic ion chart. Sulfite, when I find it, is down here. It says that it is SO3 -2. So I'm going to take this and pair it up with SO3 -2. Again, when I swap and drop, you end up with H2SO3. So I hope that that was helpful. Again, putting together all of the rules. Ide gets hydro. So ide is hydro-ick. 8 is ick. Ite is us. Have a good day, guys. If you guys have any questions, make sure that you ask.